Our last lesson for this unit is solving radical equations, which is fairly straightforward as long as all of the radicals have the same root. So in example A, we've got one radical. How do we cancel a square root? By squaring it. Whatever we do to one side, we do to the other. So we get x minus 9 equals 25. Adding 9 to both sides, x equals 34. Now again, with radical equations, similar to when we looked at solving rational equations when we had a denominator, there are some restricted domains with these. So we need to make sure that we have the correct answer and not an extraneous solution. So we've got to check our answer, substituting 34 back into the original equation. Does the square root of 34 minus 9 equal 5? Well, 34 minus 9 is 25, and the square root of 25 is 5, so that checks out. Remember, when we're looking at the domain of a radical function, when we take the square root, we're only looking at the positive answer. Also, even if we consider both answers, the square root of 25 is 5 is one possibility, so it works out either way. All right, next example, we have two radicals on the same side of the equal sign. I can't raise this to the fifth power because I wouldn't be able to distribute the fifth in because of that minus sign. So the first thing I'm going to do on this one is add that second expression to the other side. So I've got the fifth root of x plus 6 equals the fifth root of 2x minus 4. Now I can go ahead and raise both sides to the fifth power to cancel the fifth root, leaving me with x plus 6 equals 2x minus 4. Subtracting x from both sides and adding 4 to both sides, we get x equals 10. Checking our answer, substituting into the original equation, fifth root of 10 plus 6 minus the fifth root of 2 times 10 minus 4, does that equal 0? 10 plus 6 is 16. 2 times 10 is 20, minus 4 is 16. And the fifth root of 16 minus the fifth root of 16 does equal 0, so that one checks out as well. And it is within that restricted domain. We're taking the fifth root of a positive value. Two more, and then we are done for this lesson. So part C, we have a radical on one side, but not the other. I still have to cancel that radical by squaring both sides. However, on the right-hand side, I can't distribute the square in because I have a plus sign. So I have to multiply it by itself. Distributing on the right-hand side, 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. So now I have a quadratic equation to solve this. I want to get all the terms on one side and get it equal to 0. So I'm going to subtract the 15x and the 10 to the right-hand side while I combine my like terms. So I've got 4x squared, 6x plus 6x is 12x, minus 15x is negative 3x, and 9 minus 10 is 1, or negative 1. So now in order to factor this to solve, I have to use the AC method. So what multiplies to negative 4 and adds to negative 3 would be negative 4, positive 1. This one is not like the t-chart where you can just put this into the binomials. You have to factor by grouping. Factoring out 4x from my first two terms and a 1 from my second two terms. I get 4x plus 1 times x minus 1. Zero product property, setting each term equal to 0. I get x equals negative 1/4 or positive 1. Checking my answers in the original equation. Ran out of room here, so I'm going to check off to the left. 15 times negative 1/4, negative 15/4 plus 10. Does that equal negative 1/2? 2 times negative 1/4 plus 3. Under the radical, 40 fourths minus 15 fourths is 25 fourths. Does that equal 3 minus half is 2.5 or 5 halves? And the square root of 25 over the square root of 4 is 5 halves. So that one does check out. Checking my 1, square root of 15 plus 10, does that equal 2 plus 3? 15 plus 10 is 25. Square root of 25 is 5, so both of my answers check. No extraneous solution on that one. Last example, this time I have a rational exponent instead of a radical. Before I can cube that, I'm going to want to get rid of the 2. I could cube the 2 and that binomial at the same time, but more than likely you will make a mistake if you try and do that. So I would isolate the term with the rational exponent or the term with the radical before you try and cancel it. So I'm going to divide both sides by 2. And then I'm going to cube both sides to cancel my 1/3 power. 2 cubed is 8. Subtracting 1, I get 7. And last step, checking my answer in the original equation. Seven plus 1 is 8. And remember, the 1/3 power is the same as a cube root. The cube root of 8 is 2, and 2 times 2 does equal 4, so my answer checks out. And your U-try questions.